All right, so we have our last few slides of our Concept 1 notes to go over today. And so now we're going to be talking about graphing motion. So again, graphs can help us visually understand an object's motion, so we can look at a graph and tell how that object is moving. Right, so slope, you guys should hopefully remember that from Algebra 1 last year, right, is the steepness of a line, right? So it's rise over run, so it's the change in y over the change in x. So on a distance versus time graph, right, we have distance on our y-axis, right, we have time on our x. So slope in this case would be distance over time, which yesterday we learned is the speed. So we can find how fast an object is moving just by looking at a graph. All right, and so again, looking at the graph, we can determine how an object is moving. So in this first graph here, right, we have an object that is moving at a constant speed, right? So if you have a line like this, right, we're moving at a constant speed, right? It's not speeding up, right? That slope of the line is not changing. So that means that we're staying at the same speed, right? Right, since it starts down here, right? So this here is our reference point, right? Our zero line down here is the reference point. So since we're starting here and going up this way, that means the object is moving away from the reference point and at a constant speed. Right, looking over here at our pink graph, right, we're starting up here, right, so we're starting at a distance of 12. We're starting far away from our reference point. Again, our slope stays the same, so we're moving at a constant speed, but we're coming back down towards our reference point. Okay, on distance versus time graphs, when we have curved lines like this means that our object is speeding up, right? So as we continue, we're covering more distance over the same amount of time, so it is speeding up. The line is becoming steeper, right? Here, we're starting off steep, but we level out more, so that means our object is slowing down. Okay, so remember, for distance versus time graphs, there has to be like a curve in the graph for it to be speeding up or slowing down. Right, straight lines here mean that we are moving at a constant speed. Okay, so let's think about an object that would not be moving, right? So if you look here, right, we're at a distance of 5, right? So as our seconds down here pass, right, our distance is staying at 5 meters. So for an object not moving, it is just a straight horizontal line. Okay, and then in our graph down here, we've got kind of 3 different things happening, right? So we've got a constant speed from these first 2 seconds, right? Or 3 really, because we have a nice straight line with a slope, right? At this 3 to 4 seconds, or really 3 to 5 seconds, right? We flatten out, which means we're not moving. And then from that point on, we are curved and speeding up. Okay, so on the work that you guys will have to do today, on pages 8 and 9, you are going to be plotting the points on the graph and then connecting them with these lines, right? So put the straight lines kind of between them, between each point, right? Do it in pencil so that if you mess it up, you can go back and fix it, right? No pens for this. There's pencils over in the trays on the silver table. All right, if you guys need help, email me, have Miss Jones Zoom me again, whatever you need.